Hey guys, so today we're looking at 4.5's homework. Hopefully you have already looked at the lesson, taken the notes, and attempted all of the problems or many of the problems, and are here to check and see if check and see if you have done them correctly. So we are looking at 1 through 3 on page 286, and we are supposed to be solving the system of linear equations using matrices. All right, so the first thing we have to do is set it up. So I'll set up the first one the slow way, or showing everything, and then I will start to move through them a little quicker because I don't want to sit here all night. And I've not really been feeling very energetic at home these last few days. So my homework videos have been very dull. I'm just sitting here doing math at home. So we have our system of equations, and if we're going to solve it using matrices, we need to make it into a matrix equation. So here is how you make a system into a matrix equation for any of you who slept through the lesson. You need to set up an equation, which will have an equal sign, and you need to put stuff in matrices. And here's how it works. All of the coefficients will go in something called the coefficient matrix, and that is the first matrix we have. Then all of your variables, without repeating them, in the order that they are present here, so x and y, go here, x and y. And this is the variable matrix. And then we have the constant matrix that is created from the answers. So both of the answers go here. And so by placing these numbers here, that is a 2 and a 13, 2 and a 13, and then 4 and negative 3, 4 and negative 3. Then the variables are x and y. And then the answers here, negative 29, positive 29. Now, here is the kicker. Here's how you actually solve. The idea is you're trying to get that by itself. That's the whole goal. You want to get this matrix by itself. So we will call this matrix A, and we will call this matrix B. What do you typically do if you have something, I don't know, maybe like hypothetically, so this is like an example. So hypothetically, if we had something that was something we wanted to get rid of, maybe like 5, and it was being multiplied by the thing we want to solve for, typically that's x, and it equaled some other thing, we'll call that, I don't know, 10, how would you solve for x here? Well, the idea is, you might think, well, divide by 5, right? And that's a totally valid strategy, because 5 divided by 5 cancels. Wow, thank you, motorcycle outside, and making sure everyone in the whole neighborhood knows you have a motorcycle and you are in the road right now. Really appreciate you. So, I mean, I don't even want to get into it, right? So, this is a totally valid strategy for numbers like this. However, we can't simply divide by matrix A because matrix division is not defined. So we need to figure out some other way that you could get rid of the 5. And we'll do this here. Now, the other way to get rid of the 5 instead of dividing by 5 is to multiply by the inverse of 5. And the inverse of 5 happens to be, in multiplication, the reciprocal of 5, 1/5. Because 5 times 1/5 cancels. And this will always work because you'll get 5 over 5, which cancels into 1, right? This could have been any number. It could have been 10x equals whatever, something else, like, I don't know, 50, right? You would think, okay, don't divide by 10, but instead multiply by the reciprocal of 10, 1 over 10. 1 over 10 times 10 is 10 over 10, and that will cancel into 1. So the idea here is you multiply by the inverse, and the inverse changes from function type to function type, or from operation to operation, excuse me. So here, this is matrix multiplication. So we will need to use the inverse here. So we want to multiply both sides by A inverse. multiply this side by A inverse as well. And it's specifically A inverse on the left, not A inverse on the right. So this will cancel, just like these canceled, right? Just like those canceled. So we don't have to worry about that anymore. And what we end up with is that the matrix xy is equal to A inverse times this matrix, negative 29, 29. So let's go ahead and do that. You can find the inverse of this matrix by hand by taking 1 over the determinant times this jumbled up matrix. You know what? I'm going to do this by hand. I'll do the first one by hand, and then I'll show you how to do it by calculator. So the inverse of A, well, it's a 2 by 2. And so the inverse of it is going to be 1 over the determinant. And the determinant is going to be the main diagonals product. So this is negative 6 minus the alternate diagonals product, which is going to be 13 times 4, which is, was it 52? You get negative 58, not 78, 58. Okay, negative 58. You're going to multiply that by this jumbled up matrix where the 2 and the negative 3 switch spots, and then the 13 and the 4 switch sign. So this is essentially A inverse. And then that product will be multiplied by negative 29, 29. So, man, this is going to be a giant pain. This inverse is 3 over 58 because the negative and the negative cancel. Then this negative and this negative cancel. And does 58 go, can you divide 58 divided by 13? Nope. So we've got 13 over 58. And I didn't do anything wrong, right? Negative 6 minus, I wrote the problem down correctly. All right. So then we've got 4 over 58. And then we've got 2 over 58. I know both of those reduce, but I'm not going to bother. And this one's negative. So two negatives cancel each other out. So there was a negative here and a negative here. Those canceled. Here and here cancel. Here and here cancel. But here there's only one negative, so it shows up. So this is your inverse. And you're multiplying by negative 29, 29. So this is a 2 by 2. And this is a 2 by 1. So they can multiply and you get a 2 by 1. So we're going to get another matrix that has the same dimensions as this one. And to get the first row, first column entry here, you take the first row, first column and multiply them together and sum their products. So 29, happily enough, goes into 58. So 3 over 58 times negative 29. These two reduce, making 1 over 2, giving you negative 3 over 2. All right, so that's the first piece, this one times this one. And you're going to add this times this, which is going to be 13 over 58 times 29. This will reduce to 2 and 1. And then you will have 13 halves. And negative 3 halves plus 13 halves is 10 halves, which is 5. So that entry is 5. And the next entry is found by taking the second row, second column, second row, first column right here. And so when you multiply this number by this number, you're going to get, so this will reduce to 2 and this reduces to 1, and you'll have a negative 1 times 4, which is negative 4 over 2, which is negative 2. And then when you take this number times this number, this will reduce to 2 and this will reduce to 1. And then you're going to have negative 2 over 2, which is negative 1. You're going to add these two numbers together and you're going to get negative 3. So I'm going to go out on a limb and say the answer is 5, negative 3. So it's going to be 5, negative 3. Let's use a calculator and see if we're right. Look at all the places you could make mistakes here. So now I'm going to do it on a calculator. I'm going to enter in this matrix as matrix A, and this matrix is matrix B. This matrix is matrix A, 2, 13, 4, and negative 3. And then edit matrix B. And that's going to be, whoops, it's not a 2 by 2, it's 2 by 1. And it's going to be negative 29 and positive 29. And the computation we're doing is A, it's showing up right here, A inverse B. So we want to go in here, pick out A, press the inverse button. Whoops, that's the squared button. So that's A inverse, and now we're multiplying that by B. So you go back in and put in B. Look at that, 5, negative 3. So we ended up getting the same answer. It just took like 1/10 of the time. So that is how you could do it by hand. I'm going to start doing them by calculator now. So why did I... Okay, never mind. I'm doing it. Okay. So number 2. It's 3x minus 7y equals 98. Negative 2x plus 5y equals negative 69. So setting this up as a matrix equation, everyone should be able to do, even without a calculator. Even if you don't have a calculator, you should be able to create the matrix equation. So if you don't have a calculator, and actually, if you don't have a calculator, you should be working these out by hand, sadly. But if you do have a calculator, you should be able to put them into the matrix equation. There will be questions on the test where I just tell you to put it into a matrix equation. I don't tell you to solve, I just tell you to write it as a matrix equation. That is not an 8, it's supposed to be a 9. And then 3, negative 7, negative 2, 5. And for any of you wondering where these came from, man, my throat hurts. I need to take a drink. Okay. So this 3 came from this 3. The negative 7 came from here. The negative 2 came from here. And the 5 came from here. And then these two answers went here. Now, here's the way I always do it. I always call this A, I always call this B, and then I always say that the answer is equal to A inverse B. So plugging in that into my calculator, figure out. So enter in matrix A, it's 3, negative 7, negative 2, and 5. Matrix B is 98 and negative 69. So we do A inverse B, and we get 7, negative 11. So 7, negative 11. There is your solution. Number 3. This time I'm just going to jump straight into the matrix equation. Number 3. 7x minus 9y. So 7, negative 9, because it was a 7x and a negative 9y. Equals 31. So 31 goes here. Then 10x plus 5y, so that's a positive 10 and a positive 5, equal negative 45. X and y go here. Start using a calculator to solve. All right, putting in the second matrix. 31, negative 45. Do A inverse B, and you get negative 2, negative 5. All right, so far so good. Now we need to do number 10 and 11 and 12 on page 291 and 292. Now this one, I have not taught you how to do this by hand because you do not know how to find the inverse of a 3 by 3 by hand. So this is where you are just out of luck if you do not have a calculator. That is why I'm pretty positive, for any of you listening, you'll get a heads up on what's going to be on the test. I'm pretty positive, if I remember right from the test I made last year, that on the solving the system of like 3 equations and 3 variables, I just had you set up the matrix equation. I did not have you solve. So I'll go ahead and write this out for the sake of just showing you how to do it. Something to really keep in mind is that you need to be very sure that you are transferring the numbers into the matrix equation correctly. I want to specify something here. When you make your matrix, you need to make all of this column X, all of this column Y, and all of this column Z. Now, it's actually not very necessary that they're in that order, but for the sake of simplicity, you should make them in that order. So that means that this first number that goes here should be the coefficient of the X in your first equation. That happens to be all this happens to work out. You've got x, y, z, x, y, z, x, y. Wait, this should say x. X, y, z, right? But it's not always going to be the case. Sometimes you might miss a y here. So it's very important that you remember the only thing that goes in here are coefficients for x, coefficients for y, and coefficients for z. So this is going to be 7, 2, 3, -8, -1, 4. -10, 3, 5. And then the variables are x, y, and z. And then the answers are -12, -6, and 1. And the way you work these out is exactly the same, except now we're dealing with 3 by 3. Well, that's convenient. 2, 3, -8, -1, 4, -10, 3, and 5. You guys should try to get good at mouse accuracy. It really helps your video gaming. It's not a 2 by 1. It's a 3 by 1. It's -12, -6, and 1. Now we're doing A inverse B again. You get -1, 2, 3. -1, +2, -3. -1, +2, -3. There's your answer. Number 11. I'll just write it as a matrix equation. It's going to be 2, -4, 11, -3, 5, -13, 5, 10, 10. The variables are x, y, and z. And the answers are 18, -25, and 5. Now, editing your matrices again. 3 by 3, and you get 2, and -4, 11, and -3, and 5, and -13, 5, and 10, and 10. Okay, moving on. Editing the second matrix. It's a 3 by 1, and the entries are 18, -25, and 5. And that's that. A inverse B gives us 5, -2, 0. 5, -2, 0. That's number 11. Finally, number 12. Number 12 also doesn't try to trick you. But again, you really need to pay attention to that. This one I'm just going to do straight onto the calculator. The coefficients for x is 8, and then the y is 1, and then the z is -4. Always go through each variable when you're doing this. Then the next equation. Oh, they do try to trick you. They do try to trick you. Man, good thing I'm pointing. Good thing I'm looking at this. Always, when you're putting these in, like, tell yourself the x coefficient first, then the y, then the z. Because on the second equation here, the second equation looks like this. It is trying to trick you. They are wanting you to put -2 in for this entry right here, when it should not go there. The entry that goes here is the coefficient to x on the second equation. So if this is the second equation, you do not see an x. Therefore, the coefficient that goes with x must be 0. Big, big thing. And then here, these two should combine. So this should be -3y plus 2z equals -7. So the coefficient in front of the y is -3, and the coefficient in front of the z is 2. Really important that you don't screw this up. Otherwise, you're just going to get the whole answer wrong. And then here you've got 4, 5, and -8. 4, 5, and -8. You might be able to hear my clicks. half the time whenever I use a calculator, I am using my pen, right? So right now I've got an actual pen that's on this tablet, and so I can just write on this like this is like my like real handwriting. But then other times I've got like a mouse, like is what I've got here. Anyway, why do you care about that? You don't care about that. So now we're going to enter the second matrix information. Whoops. So this is going to be, the answer is 4, -7, 11. 4, -7, and 11. And now we do A inverse B. And that gives us this. I wonder if that's right. Let's look back over our work just to make sure. It should be 8, 1, -4. 8, 1, -4. 0, -3, 2. 0, -3, 2. 4, 5, -8. 4, 5, -8. And then the second matrix, 4, -7, 11. 4, -7, 11. All right, then we're good. So then we just convert this to a fraction, and we get 5/12, 8/3, 1/2. 5/12, 8/3, and 1/2. There you have it. All right, 21 minutes to do a bunch of problems that can be done on a calculator. So hopefully you guys have figured out whether you got the homework problems right or wrong, and if you got them wrong, hopefully you figured out how to do them correctly, and hopefully asked any questions if this video did not answer your initial thoughts. And I'll catch you on the next one.